Hello everyone. Welcome back to Chapter 9, Electrons and Atoms. In this little vignette, we're going to talk about how we can use our best friend, the periodic table, to determine the electron configuration, for a particular atom. So we said in the last video that electron configurations are essentially solutions to fancy equations for the quantum mechanical model of the atom. And electron configurations involve two parts. They involve two parts to an electron's address. They involve the principal quantum number, which says something about the energy level of where an electron is in an atom. They involve a number and they involve a letter, either S, P, D, or F. Those letters speak to the shape of the region of space where an electron resides, or the shape of an orbital. So we said what those shapes were in the previous video. So how do you use that principal quantum number and letter in an electron configuration, and how do you use the periodic table to predict the electron configuration for an atom? So if you don't have a periodic table in front of you already, the periodic table that you use for quizzes and exams, I would encourage you to stop the video and get it now and mark it with the trends that are shown in these little yellow boxes. I would note those on your periodic table for each region, specifically the regions that are in this video that are in blue, whatever this off red is, and green. We're not going to really talk about these elements down here at all, so you don't have to worry about writing these little trends in yellow down here. I would write down these trends, the ones that are in the little yellow boxes, on your periodic table for the areas in blue, for the areas in red, area in blue, and areas in green. Those little trends in the yellow box along with the arrows, because that is going to help you remember what principal quantum number and orbital letter to use when writing the electron configuration for an atom. So if you need to stop the video now and do that, you can go ahead and do that. On the next part of this video, we're going to be doing examples of writing electron configurations based upon those trends for the periodic table. And I have a small periodic table down here, but it'd be much easier to look at the one that you have marked in front of you. Okay. So how do we use those little hints that were given in those little yellow boxes? How do we use those when writing the electron configuration or an electron's address for a particular element? Okay. So a few things to note. So when you write down the electron configuration for an element, you need to write down the principal quantum number, you need to write down the letter, and you need to write down the numbers of electrons in that orbital. So when writing the electron configuration for an atom, first you need to know what atom you're writing the electron configuration for, and you need to know where it is on the periodic table and how many electrons it has, because that's going to tell you how many electrons need to be placed in orbitals for your electron configuration. So, for example, let's say I wanted to write the electron configuration for hydrogen. Hydrogen is right here on the periodic table. And I see that a neutral hydrogen atom, has one electron. How do I know that? Because hydrogen has one proton, according to its atomic number. Protons are positively charged, so that means I need to have the same number of electrons. So a hydrogen atom has one electron. I'm going to use this E-1 to mean electron. So that means I need to have a home. I need to place one electron in my electron configuration. Okay. So how do I start writing down orbitals for my electrons? I have to start at the very beginning of the periodic table and just travel across it, making sure I place the correct number of electrons in the orbital that is designated in my little yellow box. So for example, let's say I'm going to do hydrogen. I know I have the answer here, but let's talk about why it is. I've got hydrogen. When I start placing electrons, I have to start in an orbital that has a principal quantum number of 1. It's a principal quantum number of 1. I have an s orbital. That's where the s comes in. And in that 1s orbital, I am going to place 1 electron. So I note that the fact that I'm placing 1 electron in this 1s orbital by putting a superscript. So 1s1, that is the electron configuration for hydrogen. That tells me that for a hydrogen atom, I have 1 electron in a 1s orbital. What if I wanted to do the electron configuration for helium? Well, helium I see is over here in my periodic table. How many electrons does helium have? Helium has atomic number 2, so helium has 2 electrons. So that means I need to place 2 electrons in my electron configuration while following the trends that I have here. So anytime you write the electron configuration for an atom, you start at the beginning. So I'm going to start here at the beginning here of my periodic table. I'm at 1s, so I have a 1s orbital. So I'm here at 1s. If I had 1s1, that would be hydrogen. I need to go to helium, so that means I need to place 2 electrons in this 1s orbital. 1, 2. So that 2 becomes a superscript. So my electron configuration for helium is 1s2. So I should note that the superscript here is equal to the number of electrons in your atom. Okay. So that is the electron configuration for helium. In this slide, we're going to go through some more examples. What if I wanted the electron configuration for lithium? I see lithium here on my periodic table, atomic number 3. So lithium is going to have 3 electrons that need a home. When giving electron configurations, I got to start from the very beginning of the periodic table, back at hydrogen, because I have 3 electrons I need to place. So I'm going to start with hydrogen. And I'm going to count until I get to the element that I need to do an electron configuration for. So I have to start with 1s1, 2. So I have 1s2 to start my electron configuration. But if I just left it as 1s2, that'd be helium, right? I need to get to lithium, which has 3 electrons. Right now I just have 2. So I have 1 more electron to place. I can't place it in that 1s orbital because my little key here on my electron configuration says that I have filled up all my 1s orbitals already. So that 1 electron for lithium has to be in a 2s orbital. So my final electron for lithium gets placed in a 2s orbital, and so 2s1. When I add up the numbers, the superscripts in my electron configuration, I get 3 hey, that's how many electrons I needed to place for that element. So I can feel comfortable that my answer is correct. So lithium has an electron configuration of 1s1, or sorry, of 1s2, 2s1. Let's do carbon. Here's carbon sitting over here. Ooh, it's sitting over here with all the green elements. And this row of elements is going to be using a new kind of orbital called a 2p orbital. But before we get to using 2p's, we got to start with our 1s orbitals first. And note that carbon is atomic number 6. So for carbon, I need to place 6 electrons. So I got to start from the very beginning again. I can't just start placing electrons here. I have to make sure I place starting at the very beginning. So I'm going to do 1s2, 1, 2. Go back over to atomic number 3 and start placing electrons there. 2s, 1, 2. If I was to stop there, that would be the electron configuration for beryllium. I need to get to carbon, so after I do 2s2, I have to travel over to where my 2p's are. And how many electrons do I have to place before I get to carbon? I have to place 1, 2. So and then I'd stop, because now I have placed a total of 6 electrons. 2 plus 2 plus 2, that gives me 6 electrons. So that is my electron configuration for carbon. 1s2, 2s2, 2p2. Lots of fun, right? So let's continue on. Let's do fluorine. Here's fluorine on my periodic table. Has 9 electrons that I need to place. I'm going to start at the very beginning again, just like I did with the previous 2 examples. 1s2, 2s2, travel over here to the p's. How many electrons do I need to place to get to fluorine? I need to place 1, 2, 3, 4, 5 electrons in the 2p's. I stop because I am now at fluorine, which is what I wanted. And I double check to make sure I have given 9 electrons a home. 5 plus 2 plus 2. That gives me 9. So that is the electron configuration for fluorine. Let's do 2 more. Magnesium. Got to start at the beginning again. So 1s2, 2s2, travel over 2p, 1, 2, 3, 4, 5, 6. Once I stop at 2p6, that would be the electron configuration for neon. I got to have the electron configuration for magnesium. So after neon, I got to come all the way back over here to where sodium is. I'm going to start using a new orbital called 3s. And in that 3s orbital, I have to place 1, 2 electrons. So my electron configuration for magnesium is going to end with 3s2. And again, you can add your superscripts up and make sure that you get 12, which is the number of electrons magnesium has. And so that would be the electron configuration for magnesium. Let's end this video with doing the electron configuration for Sc, scandium. Atomic number 21. So that means we have to place 21 electrons in orbitals to get the electron configuration for that element. So our wrist is going to get a little tired, but we can do it. We got to start at the very beginning again, though, because we have to place 21 electrons. So started hydrogen, 1s2, 2s2, 2p6, 3s2. If I was to stop at 3s2, that would be magnesium. I'm going to travel over here to my 3p's. 3p. How many am I going to place in the 3p's? 1, 2, 3, 4, 5, 6. So I've got 6 in my 3p's. That gives me argon. I'm going to travel back to potassium here, to my 4 S's, because I eventually got to get to 21. But before I get to SC, I have to place 1, 2 electrons in the 4s orbital, and 4s because that's what my little cheat sheet says here in my periodic table. If I was to stop at 4s2, what element would that give me? That would give me the element, that would give me 20 electrons, that would give me calcium. I got to get to SC. So I have 1 more electron to place. That electron, though, is not going to go in a 4s or 4p. That's going to go in an orbital that is 3d. Now, why that principal quantum number is not 4 and 3 is something you talk about in Chem. We talk about it a little bit here, but mainly Chem 1. You should just know that with these transition metals, the principal quantum number goes down 1. And so that 1 electron for SC is going to go in a 3d orbital. So specifically, it will be 3d superscript 1 because I placed 1 electron in that 3d orbital. And so you can add up these superscripts, make sure that they are 20, add up to 21, the number of electrons in that element. And that is the electron configuration. All of this is the electron configuration for SC. So I encourage you to try some of the electron configurations that are on the Chapter 9 worksheet that I've put on Canvas. In the next video, we'll do just a quick review of electron configurations, and then we will move on to something that are called orbital diagrams. Have a good rest of the day.